All right, we're going to tackle the last 4 examples in the notes here. So let's give it a go. First example, example E. So we could see that we have this base here, this m divided by n in brackets, all to the power of 3. But we'll also notice there's this 7 out in front. Now that 7 is not part of the brackets, so when we distribute the exponent of 3, that does not go on the 7. The 7 simply remains as is. That exponent of 3 will distribute to both the numerator and the denominator, leaving us with m cubed and then n cubed in the denominator. The 7 stays as is. Now, because the m and the n have different bases, we cannot further combine anything. So example E is all done. Example F. So, a couple of things that we can do here. I noticed that my base is in brackets, and in this time, the whole entire rest of the question, other than that exponent, is in that bracket. So everything within that bracket will get the distributed exponent of 2. But before I do that, one thing I might notice is that part of my bracket can be reduced. Now, I don't have to do this right away, but the sooner I do it, the smaller the numbers I'll end up with at the end. So I'm going to start by reducing those numbers. So here I have 3 in the numerator, I have 6 in the denominator. Both of these values can be divided by 3. So I'm going to go ahead and do this, and I will end up with 1m squared as my numerator, which I know I don't have to include that 1 as the coefficient there because it's a little bit redundant. And in my denominator, 6 divided by 3, that gives me 2, leaving me with 2n to the power of 5. Now, because I didn't actually distribute that power of 2 quite yet, I do need to make sure that my reduced bracket remains in brackets once it's been reduced. And now I'm ready to go ahead and distribute that exponent. Remember, that exponent gets distributed to every single value or within my bracket here. So it gets distributed to that m squared in the numerator. And m squared taken to the power of 2, that power of a power law, means I multiply those exponents. So I get m to the power of 4. Now in my denominator, that 2 also gets that squared. Just because it's a coefficient doesn't mean it doesn't get to enjoy that exponent. So I get that 2 squared, and then n to the power of 5 also gets raised to the power of 2, and I multiply those exponents. 5 times 2 is 10. Now I'm so close to done because I have only positive exponents. Nothing has the same base, so they can't be further combined. But I can further simplify because I know that 2 squared is just 2 times 2, which is 4. Now that 2 squared is in the denominator, so that 4 will also remain in the denominator. It doesn't move anywhere. And this here is my final answer. We have 2 examples left, and now if you haven't tried it quite on your own, please pause and take a go at it. Did you do it? Did you pause? I hope so. Okay, we are going to tackle these last 2 examples. So for example G, I'm looking at my my power here, and I notice that everything except for that exponent is within brackets, which means it's part of my base. Now I'm looking at my base, everything within those brackets, and thinking, could I reduce anything? Not quite. There's no numbers I can reduce, no powers with similar bases, so I go ahead and just start by distributing that exponent to every single value within that base, both numerator and denominator. And just like in the previous question, I multiply the exponents on my power. So s to the power of 5 raised to the power of 3 gives me s to the power of 5 times 3, which is s to the power of 15. Now, you'll notice that -2 is a number that was in the brackets of my base. Now that negative also gets that exponent of to the power of 3. So I'm going to keep that negative in brackets with that 2, so that that negative, when taken to the power of 3, is included in that repeated multiplication. Just because we have that negative here in the repeated multiplication, if we wanted to write it out, we also must include it when we apply that exponent law. And last but not least, we have t to the power of 4 times 3, which is 12. Again, so very close to being done, but not quite yet. Although the s to the power of 15 and the t to the power of 12 are ready to go, we can actually go ahead and evaluate negative 2 to the power of 3. Because we know negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is going to give me negative 8. So I'm going to end up with a negative 8 in my denominator. Now this here is my final answer. Something to kind of keep in mind if we're ever checking answer keys online, just like we talked about in the fractions unit, when we have a negative fraction, it doesn't quite matter where that negative is. If it's in the numerator, if it's in the denominator, if it's out in front of the whole entire thing, we still end up with a negative fraction. So if we ever saw something like this, where the negative was moved to the top rather than the bottom, it wouldn't actually make a difference in our final answer. Or we might even see the negative out in front of the whole entire fraction. In either case, as long as there is one negative somewhere within that fraction, top or bottom, we end up with the same final answer. Of course, we only want a maximum of one negative sign in there, because if there were two, a negative divided by a negative would end up being a positive. So either way that you express this final answer will be accurate. Of course, as mentioned in last unit, the negative out in front of the numerator or the negative out in front of the entire fraction is more preferable than leaving the negatives in the denominator. It's just kind of a math grammar thing. Okay, last but not least, example H. So I'm looking inside my brackets here to see if anything can be simplified, and we cannot. If we wanted to, we can go ahead and move that n to the negative 8 to the numerator. I personally don't want to do that right away because I'm noticing that my exponent is negative. And so I know that I will have some flipping going on at some point, and I don't want to have to do it twice, so I'm just going to tackle that all later on in my work. Since my whole entire base is within the brackets, I know the negative 2 applies to every single value within that fractional base. And just like before, since that negative was inside my brackets, the negative must be included in the repeated multiplication. So when I distribute that exponent of negative 2, my negative must be included in that base of my 3. So I have negative 3 all in brackets to the power of negative 2. I have m to the power of 3 times negative 2, which is negative 6, all over n to the power of negative 8 times negative 2, which is positive 16. Now, of course, my answer is not complete, and you knew that, because I have negative exponents here. Reminder, we cannot solve or evaluate negative 3 to the power of negative 2, because there's no way to write out a negative exponent as repeated multiplication in a way that makes sense quite yet. But we know that we can go ahead and turn that exponent into a positive exponent by flipping that into the denominator. So we're going to go ahead and move that negative 3 to the negative 2 to the denominator, making my exponent a positive 2. We're also going to do the same thing with our m to the negative 6, because we want to have a positive exponent in our final answer. And if we're looking at our n, well, n's already a positive exponent in the denominator, so it needs to stay there. And of course, right now we don't have anything in our numerator left, so of course there's that secret numerator of 1. that when no one else is there, comes out to shine. Now we are so very close once again to our final answer. We just have to go ahead and simplify that number, that -3 to the power of 2. My m's to the power of 6 and my n to the power of 16 are as simplified as they can be. They don't have the same base. They can't be combined. They're all positive. Life is good. So we are going to go ahead, leave those be, but we are going to evaluate -3 squared. -3 times -3 is a positive 9. And at this point, we have simplified to its full extent. And we are done. All right, we have now completed these 4 examples with the rest of the notes. And you'll notice that there is practice to follow. Please make sure that you attempt all of this practice. You check all of your final answers to make sure they're the same. And send me any messages or ask me any questions if you get stuck. Have a great rest of your day.